Good afternoon, Geometry Honors students. So this one is for the big idea, sections 5.4, angle side theorem. Objective, apply theorem relating to angle, measure, and side lengths of triangles. So let's just record an isosceles triangle. So isosceles triangle, what do you guys notice? So it's about the segment AB, it's congruent to segment AC, and then the base angle's got to be congruent as well. So for the angle side theorem, it's saying that if segment AB is congruent to segment AC, then angle B is congruent to angle C. The converse statement, so we just need to swap the hypothesis and the conclusion. So just state that if angle B is congruent to angle C, then segment AB is congruent to segment AC. Okay? So now, let's see what we got here for the example. So given that angle 5 is congruent to angle 6, and then JG is the altitude to FH. Okay, so two-column proof. So it's always based on the fact for the proof. So started with the given. So statement and reason. So started off with angle 5 is congruent to angle 6. Given. And also JG is the altitude, which is the height, to segment FH. It's also part of the given. So anytime they see that there's the altitude of a triangle, so that means that line segment, the altitude, it's always considered perpendicular to the base. So JG is perpendicular to FH. Segment JG, okay, put a bar there. And the reason why for this one is because the definition of an altitude of a triangle. And then another thing that I can state here is that angle JGF it's congruent to angle JGH, in which equals 90 degrees. So this one is combined with the reasons of definition of perpendicularity and also the congruent angle. So I just need to state one of those, definition of congruent angle with perpendicularity. Okay, so continue with the proof, statement and reasons. Now one thing that we noticed, this one, it looks like can be proved by what? Using angle side angle. So also you want to state that JG is congruent to segment JG. It's the same element. So this one is by using reflexive properties of equality. So therefore, triangle JFG is congruent to triangle JHG. And the reason for that is by using angle side angle. And then the next thing that you want to state here is that angle F is congruent to angle H. So by using CP/CTC. And also another thing that we can state here is that segment JF is congruent to segment JH. It's also the reason for CP/CTC. And then finally, so we can say that triangle FJH is an isosceles triangle. Statement reason, so the final statement, so triangle FJH, it's isosceles. Reason for that? This one I would say that is by the angle side theorem. Well, because that, if the base angles are congruent, so that means the corresponding segments, the sides, got to be congruent. So by the definitions, so of an isosceles triangle, so this one it just formed an isosceles triangle. Okay, so now let's see what else that we have. Finding the boundary, write an inequality to describe the restriction. Okay, that's misspelling. Restriction. On X. So one thing that we notice, angle B plus angle C, it's less than 180 degree, obviously. So we can set up that 5x minus 10 plus 4x, it's less than 180. Because the measure of all the angles of a triangle, it's always equal to 180. Since we're just adding the first two angles, up two interior angles, so this one is always less than 180. Another thing that we notice is the inequality. So segment AB is less than segment AC. So what does mean that is showing the hinge theorem? So what the hinge theorem is saying that if the corresponding segment, one is less than the other, so that means the corresponding angle is also considered less than the other angle. So segment AB, it's less than segment AC. So that means, well, the corresponding angle, the one facing across, so that means angle C, it's less than angle B. So in other things that we can set up here is that 4x, it's less than 5x minus 10. Okay? So now let's find out what that is. So starting with the first inequality. So 5x plus 4x, then that'll be 9x. Less than 180 plus 10, so it's 190. So x is less than 190 over 9. And then for the second inequality, so swap that 4x and negative 10. So we got 10 is less than 1x, because 5x minus 4x. So 10 is less than x. In other words, x must be greater than 10, but it's less than 190 over 9. Okay, so the boundary. So x is right between 10 and 190 over 9. So that would be the restricted value for x. Okay, so now let's see what else that we have for the rest of this. Another proof. Given that segment AC is congruent to segment BD, angle ACD is congruent to angle BDC, BDC. Okay, so angle ACD, this whole thing right here, is congruent to angle BDC. Okay, so the bottom base. So again, proving that triangle ECD is isosceles. So one thing at a time. So statements, reasons. So always start with the given. So this one, the proof is going to be a little bit long, so I'm not going to rewrite the given statement. So just refer back here on the top. So it's all given. So since we already know that all those segments, the angles are congruent, so one thing that we notice, CD, it's congruent to CD. By using the reflexive property of equality. Okay, so therefore triangle ACD is congruent to triangle BCD. And the reason for that is by using psi, angle psi. So this one is just like an overlapping triangle here. So proving those two triangles congruent. So psi, angle psi. Now, in order to show that triangle ECD is isosceles, so what we can do here, we can figure out that the base angle. Okay, so another things that we can state here. So angle ADC is congruent to angle BCD. And the reason for that is CPCTC, corresponding part of congruent triangles, are congruent. So once we show that those two angles here are congruent, So another thing that we can state next, the segment. So statements and reason. So now segment EC is congruent to segment ED. And the reason for this one is by using angle side theorem. So if the base angles are congruent, the corresponding segments got to be congruent as well. And therefore, triangle ECD is isosceles. And the reason for that one is by using definition of an isosceles triangle. Alright. Okay, so now let's see what else that we have for the rest of this. So here's another example. So given that triangle FED, it's equilateral. If that's equilateral, that's, it's going to be pretty straightforward. All three sides are equal. And then all three angles got to be what? 60 degrees. Another thing that we notice, segment GE is perpendicular to segment DE. So this one is perpendicular to segment DE, so this one is formed 90-degree angle. And now what we notice, measure FEG. Okay, FEG, this angle here, it's x plus y. Angle D, 3x minus 6. Angle F, 6y plus 12. Well, what we can start at first, we can start it all with solving x, right? So finding out that angle D there, so 3x minus 6, we do know that's 60 degree because that angle, triangle FED, it's equilateral. So that means all three angles got to be 60 degree, 180 divided by 3. So solve for x first. So 3x equals 54 divided by 3. So x equals 18. So once we solve for x, so it looks like we can solve for y, but we need to set up the equation for y. So another thing that we notice, angle F is 6y plus 12. So that means 6y plus 12 equals 60 degree. Using the equilateral triangle, the measure of each interior angle is 60 degree. Subtract 12, so we got 48 divided by 6. So y equals 8. So after we solve for x and y, so what can we do? So we can solve for angle F, which is 6y plus 12. So 6 times 8 plus 12. So 48 plus 12. Then that'll be 60 degree. Okay, so this one is not that bad. It's actually pretty straightforward. Okay, so now let's see what else that we have. That's it. So pretty much, so for this one, if you see the overlapping triangles, okay, like the previous one, well, this one there's no overlapping. It's just about using the angle side theorem. Well, sometimes you might be dealing with the overlapping triangle, like the previous video. Alright, so thank you for watching that 5.4 lesson today. So I'll see you guys next time. Have a great one.